PolyIC is a company in Germany located. We are already about 9 years old, started as a joint venture between a printing company and an electronics company. Now we are 100% owned by a printing company which does specialty films. PolyIC actually is really one of the oldest companies in this area, and also our vision is really the long-term vision of putting an identification to every product. So the Internet of Things vision of how to put and code and read it from a machine so that you can identify where a product is coming from and where it is going to. We've developed that for several years, and we are still doing ongoing development, but we recognized it takes such a long time that it is maybe useful to start to use some of our developments already for business, so that we use developments which we have made, production we can do already for business which is existing, and not wait for a future vision and future business which may come in the future and hopefully will come there. And that is what we have done so far. So we started to use technologies, started to use production technologies and also our production machines to now go into a business area which is the trend in the industry right now. It's the use of touch interfaces for products. Of course, everyone knows the mobile phone with the touch interface. And we see that touch interfaces are now used and requested by a lot of other industries. We see requests from the automotive industry, we see interest from consumer industries like every, let's say, dishwasher, every refrigerator which has control buttons. They want to use, instead of a control button, a touch interface. So that you just touch to switch on and off a function. And they use for that, they want to enhance the surface of the product so that it can sense the touch. And that is exactly what we can do with the products we have been doing so far. Obviously the biggest one, of course, because the touch screens which are built in a mobile phone are large touch screens, and if you compare that to the size of a button, it's smaller. But if you look at the size of possibilities, I would say the touch possibilities in other industries could be even larger. But they just learn what they can do, and therefore we try to provide demonstrators to enable these thoughts and give them the idea what can we do. And actually we also thought that it is a good idea not only to say this is a function, but also to give them ideas how easy it is to integrate, and even how low cost, how efficient it could be integrated in future surfaces, in future devices, and in future automotives. And that is what I have with me here. This is actually a device which is made by injection molding. This is a typical way to do surfaces for the automotive industry. So it is a plastic part. And of course, for this plastic part, until now, what you do, you have a decoration on front. So this is plastic, but it has a decoration in front which makes it look very nice. But what can be now done, and that is really something which is enabled in a new way, is that in the same moment as this plastic device is produced, it is also touch enabled. So on the back you see a film, and this film actually contains structures which we have produced. This contains the film, which is our product, which enables touch operation for this kind of devices. So maybe you find in the car tomorrow the air condition control or the heating elements for the seats, and you touch it to switch it on and off, and this is invisible for you, but it works then perfectly in the back. Our product is sensing the touch and is, let's say, making this operation happen. The advantage is, of course, it's fancy, but it's also cost efficient because it's produced very efficiently, and it's now getting just a part of the surface and not only an additional element. So it's easier to integrate, and that is something automotive producers like, and hopefully also the consumers like. Of course, it is. That is something we talk in the OEA a lot. Is the new things which we have developed, and that was, of course, the work we've put in since years, is to develop this process which enables us to print very precisely these structures on the film, on the polyester film. So that is something we developed for years, but the use of it now is very easy. So that should be not the challenge anymore. The challenge for us is to print these structures, but this is something we developed for years. So one of the steps definitely is, right now we are doing a lot of, from the marketing side, we do a lot of feasibility tests together with customers. So for us, hopefully the next step is that some of these feasibility studies really turn into production process, turn into mass production. So ramping up of production is our next step on the business side. On the development side, we see that we can use this structure really to do full electronics, full circuits. So do transistors based on that, so that it's not just a sensor, but the full intelligence is built in such kind of films. So that is really following the vision of printing electronics to film. This is something which is enabled by this technology, but that obviously requires more development, still ongoing, but hopefully combined with production and business. Yes, that could be helpful, but to wait for graphene coming into this, yes, we will look at it. What we are right now waiting for is we need semiconductors. So graphene is a conductor. We need semiconductor devices, which is exactly the silicon function of standard electronics, based on polymers, so in solution, so that we can put them here roll to roll on this film. So that is one of the things we are waiting for out of the industry, from chemical companies, good semiconductor, which really enables then complete logic, complete intelligence here. Today it's a sensor, tomorrow it's really intelligent. I think the potential possibility, or the possibilities of combining this with different aspects is, I would say, even indefinite. It's more the challenges to select the ones which enable fast development. So one of the things, for instance, we've done in the past was we combined with such companies to develop temperature sensors to sense in the biological area, to sense the quality of a product by just measuring temperatures and other conditions. So maybe we start always in with the low-hanging fruits, start with the simple things and then develop further, because of course we see the visions in the very future, but we've learned that we have to start small to make things happen as fast as possible, because everything costs money, and the financial people wait and expect results. So we think it will be possible in the future to do a lot of things based on this technology, but we start now, and we start with small steps to come into this bright future. So the base material is polyester, so PET, which you see everywhere in the packaging industry. The conducting material we are using here is silver. It's a very precise structured silver, and also very thin printed. Yes, one of the things, or the key learnings And this is actually, I was one of the founding members of the OEA, was from the very beginning, it was clear that no company can do everything alone. So you have to connect, you have to network with other companies, and you have to learn about what they can do and what you can do, and how you can collaborate to be faster, to be more efficient or closer to customers. And that is why we do such kind of meetings, and I enjoy the meeting here, especially here at Cetemmsa, to learn about their capabilities in areas we are not yet active, and maybe by combining competencies, this enables future business and enables future application space.